Every day, about 1,500 flights go from the US to Europe, and most of them use only this special route over the Atlantic Ocean. This is a kind of invisible highway of ships, in which all the ships fly back and forth 60 kilometers from each other. Sideways are 30 kilometers apart, while altitudes are only 1,000 feet above and below each other, means about 305 meters. You must have experienced it yourself or seen a video in which multiple ships are very close to each other in the sky. This is especially seen in flights from the US to Europe, in which this invisible highway is used. But the question is, when the entire sky is empty, why do pilots stay close to each other and use only this special route in extremely risky situations? Welcome back to Topotrove. This invisible highway of shipwrecks was discovered about 100 years ago. In 1920, a Japanese meteorologist named Wasaburo Oishi sent several weather balloons in the sky for research purposes. He noticed that at an altitude of 30,000 to 40,000 feet, there is an invisible force in the sky, which takes the balloons to the east at a very high speed. The world did not pay much attention to his research, but after 25 years, there was an incident in World War II, which made the world start taking Japanese scientists' research seriously. In April 1945, 6 friends went to Oregon to celebrate a picnic, and they saw a huge balloon lying in the forest. They came in excitement and pulled it, but they did not know what kind of danger they were going to take. There was a bomb in that balloon which exploded and 6 friends died. Many such incidents were reported in the US. When the investigation was done, it was found that these balloons were launched by Japan across the Pacific Ocean, 10,000 km. Not only 2 or 4, but Japan launched around 9,000 balloon bombs, of which 300 were targeted in the US. Japan took advantage of the research of Wasaburo Oishi and launched these balloons, which reached the US in the fast winds. Since then, this tunnel of 30,000 to 40,000 feet above sea level is known as jet streams. These balloons travel at a maximum speed of 250 kilometers per hour to the east almost the entire year. They have been noticed in the northern hemisphere and in the southern hemisphere. They travel in the shape of a tube which is several hundred kilometers wide and 4 kilometers thick, and the surprising thing is that they do not have any fixed location. Scientists believe that these high winds are caused by the temperature difference between the poles and the equator. When the warm air of the equator travels towards the pole, jet streams are created, but if the wind travels from the equator to the North Pole, it should go south to the north. But why do these jet streams travel from west to east? The biggest reason for this is the rotation of the Earth. Our Earth is rotating anti-clockwise direction, i.e. from west to east at a speed of about 1,600 kilometers per hour. In the northern and southern hemisphere, these high winds should travel towards the poles, but the rotation of the Earth forces them to travel from west to east. Now let's come to our main question. Why do 1,500 aeroplanes use only one path per day to travel from the US to Europe over the Atlantic Ocean? In 1952, airline pilots started paying attention to jet streams, as the Pacific Ocean also has jet streams. The same way, there are jet streams on the Atlantic Ocean during the journey from the US to Europe. During the journey, pilots intentionally took the ship into the jet stream because the air of 250 kilometers per hour pushed the aeroplane forward. This increased the speed of the aeroplane. The turbulence also decreased, and the fuel was also saved. Similarly, if you want to go back to the US from Europe, then the pilots would use any other route, but would stay away from the jet stream, because now these winds were in the opposite direction, which would have an opposite effect on the ship. Time passed and the airline industry grew rapidly. All pilots started using jet streams to go to the east, but the biggest problem was the increasing traffic in the jet streams, which could lead to accidents. This work was done by the air traffic controller, or RT, to make a route plan of the flights according to the weather, so that no ship collides with each other in the jet streams. We all know that the radars on the air traffic control tower detect the location of the aeroplanes. On the basis of this location, which plane will fly at what altitude and at what speed. ATC manages all this only after knowing their location, but the problem is that the range of these radars is not that much. They can detect the position of the aeroplanes in a range of more than 128 kilometers. That is to say, the range of New York ATC radars is only as much as this circle, whose radius is 128 kilometers. As soon as the ship goes out of this circle, it disappears, vendrome the range of the radar. So how will ATC know the location of the aeroplanes? The ocean is spread over thousands of kilometers. The aeroplane that flies over it sends a satellite or high radio frequency to the control tower after every 14 minutes of its position. But any accident can occur in these 14 minutes. That is why a new system was introduced in 1965. It is called the Northern Atlantic Organized Track System, or NET-OT. In this system, multiple route paths were made for flights to America and Europe, which are controlled by 4 main centers in the Atlantic Ocean. The first is New York Station, which controls this part. On the second number is Canada's Canada-Newfoundland, which controls this region. Santa Maria Oceanic Control controls this part and the Shen-McNadron part. There are a total of 6 routes of NET-OTs, whose names range from netter to net. Before takeoff, one of these routes is allocated to the pilots, or if there is more traffic on a route during the flight, then they are shifted from one route to another. These routes are specially made in such a way that the traffic splits and the ships going to Europe get tailwind. Tailwind is the wind that comes from behind the ship and pushes it. To make these routes more efficient, the location of the jet streams is seen twice a day with the help of weather satellites. And then the routes are optimized accordingly. As you can see on this live wind map, this is the USA on the left, Europe on the right, and the Atlantic Ocean in the middle. At sea level, the Atlantic Ocean has a wind speed of 22 kilometers per hour. This whole white portion is actually a jet stream, which is spreading from the USA to Europe. The 6 routes of NET-OTs are kept inside this jet stream, so that if the plane's location is not updated to the ATS for 5 or 10 minutes, then the autopilot system of the plane can maintain its speed, altitude, and latitude according to the conditions of the NET-OT routes. This is why the planes going to Europe only see us fly on this route. To confirm this, let's turn to the live plane tracker. Here, all the ships going to Europe in this part of the Atlantic Ocean are traveling in a line, while the planes coming back can be seen very far from this jet stream. Viewers, I have tried a lot to explain this concept in simple words. I hope you have understood this small video of Topotrov. Thank you very much for your loving comments. See you in the next great video.